Okay, so we're going to look at how to graph exponential functions. So mine's kind of squished here a little bit, my different functions here. But first we're going to look at this one, f of x. Now what we're going to do is make a table of values. So I'm going to put in x, f of x, input, output. And I'm going to use the numbers -2, -1, 0, 1, and 2. These are all part of the domain. The domain is all real numbers. But if you put in a -2, what is 2 to the power of -2? Well, that's 1/4, right? A negative makes it reciprocal, but you have to square the 2. You're going to get 1/4. And by the same token, you're going to, if you put in -1, you're going to get 1/2. Now, 2 to the 0 power, that's going to be 1. And then if you put in 1, you're going to get 2. 2 to the first power is 2. 2 squared is 4. Let's go ahead and do 3 because 2 is kind of a small number, and we're going to get 8. And so then this is what the graph looks like. -2, 1/4, kind of just above the x-axis. -1, 1/2, 0, 1, 1, 2, 2, 4, and 3, 8. And I think we've graphed these before a little bit in the last video, but you get that picture to look something like that. Now we want it to be accurate. We're going to be working with these a little bit, so we do what we can. And that's an increasing function, and we'll talk about some characteristics in a minute. Now let's see what happens when we go to do x and g of x. Well, that's 1/2 to the x power. So I'm going to use the same numbers. Actually, I can go with -3, -2, -1, 0, 1, 2. I'll go like this, and you'll see why in a minute. But if you put in a -3, so 1/2 to the power of -3, well, that's going to make it be 2 to the 3rd because you have to do the reciprocal. So you're going to get the 8. And then here you're going to get the 4. Here you're going to get the 2. You're going to have 0, 1. That will still, 1/2 to the 0 power is still going to be 1. Then you're going to get the 1/2, and then you're going to get the 1/4. So now you can go through and write that out and show the table of values, but for space and time, I'm just telling you what the numbers are. But you might want to spend some time doing that. Okay, so what does it look like when we go to graph it? -3, 8, which is up here. -2, 4, 1, 2, 3, 4. -1, 2. And then it's going through that point again, 0, 1, 1, 1/2, and 2, 1/4. And so we get the picture to look like this. And you can see it's reflected about the y-axis. We're going to talk about that in this section. Also note that there's an asymptote here along the x-axis for both of these functions. Okay? All right, now our last one we're going to do, we're going to change that base number. See, we had 2, and then we had 1/2, which is just the reciprocal of 2. But now we're going to go ahead and change it and see what happens when we have a 3. So if I put in -2, -1, 0, 1, 2, if I plug in -2, I'm going to get 1/9. If I plug in -1, I'm going to get 1/3. Again, you have to think about the reciprocal and what happens. 3 to the -2 is 1/3 squared. I have a little more room, so I'm writing it out for you so you can see it. But that's where the 1/9 comes from. When we say 3 to the 0 power, again, that's going to equal 1. 3 to the first is 3, and then 3 squared is 9. Okay, let's see what happens when we graph these. So -2, 1/9. That's actually below. It's going to be hard for me to draw it, but it's below that number of 1/4. 1/9 is smaller than 1/4, so it's below the black line. It's really hard for me to draw because it's such a small grid. It's not on the x-axis. It's still above the x-axis. Where's the 1/3? Well, 1/3 is less than 1/2, so it's below the black line. 0, 1, and then we have 1, 3. See, now it's above the black line, and then 2, 9. So it looks like this. Okay, so you can see, hopefully you can see, this part is decreasing quicker than when we had a base of 2. And this part, to the right of the y-axis, is increasing quicker than when we had a 2. And they have that kind of crossover thing happening. Now, if you had a different base like 4 or 5, it would be even more steep going up to the right and less steep, I don't know, it'd be below the green line on the left side. Okay, so characteristics. All of these have horizontal asymptotes at y equals x. So for all three of those functions, the horizontal asymptote was y equals x, sorry. Y equals 0, that's what I meant to say. Okay, the domain for all three of those functions is negative infinity to infinity. The range is from 0 to infinity. The x-intercept, there are none. For any of those functions, it's never crossing the x-axis. And the y-intercept, it's on these three functions, was always 0, 1. Now, increasing or decreasing? Well, it's an increasing function if b. Now, I'm talking about, f of x. That's not what I wanted to write. We're talking about the form f of x equals b to the x, where we have some base here, okay? That's what was happening for those three functions. So it's increasing if the base is greater than 1. It's decreasing if the base is less than 1. And we know the base has to be positive, so I'll say that in there too. Okay, so we'll look at more of these graphs, and then we're going to look at the transformations.